than 3/4. Okay, so this is lesson 4 out of 5. If you can't tell, I'm just moving us through this unit. We're not doing a quiz or anything because there's only 5 lessons. Okay, this is derivatives of inverse functions. So, and I think our next lesson is like derivatives of inverse trig functions. So, how do we deal with the inverses? How do we deal with the derivatives? Okay, so recall from previous courses that a function y equals f of x is 1-to-1 and will pass the horizontal line test and will therefore have a unique inverse function. Okay, so we talked about that in pre-calc. If a function is 1-to-1, it passes the vertical line test because it is a function, and passes the horizontal line test if it has an inverse. Okay, now we talk about the function and the original function. You sometimes will talk about them undoing each other. And this relates, I actually just taught this the other day in Algebra 2, or pre-calc, Algebra 2, where basically that when you compose a function of its inverse, it will always equal x. Like in Algebra 2, we talked about f of g of x equals x, or fog equals x, and we talked about goff equals x. Same type thing here. When you compose them, they equal x. A function g is the inverse function of the function f if, same thing we just talked about, f of g of x equals x, and g of f of x equals x. So again, that would be talking about fog and goff, both equaling x. And then we talk about an inverse, f inverse of x, but in AP, you'll sometimes talk about, like, they will sometimes define g to be the inverse. So you have to watch as we go through problems, what, are they using g as the inverse? Because they often do that. Okay? And then the reflective property of inverse functions. The graph of f contains the point a comma b if and only if the inverse contains the point b comma a. Remember we talked back in Algebra 2 and pre-calc. How do you get an inverse? Well, if they're ordered pairs, you just take the ordered pairs and you switch them. If it's an equation, we took x and y and we switched them. Okay, so that's the same idea with an inverse. Okay. Example 1 here. Ask us to use the reflective property of inverse functions and the function values for f and g in the table to the right to complete the tables of values for the respective inverse functions, f inverse and g inverse. Then use them to answer the questions below. Okay, so realizing this chart up above. The first column are your x's. Second column is f of x's that pair with the corresponding x's. And third column is g of x that pairs with x's. Okay, the table of values for f inverse of x. Thoughts? Switch the x and f of x, right? So basically we're switching the first 2 columns here. Yeah. So the ordered pair for f of 3, 2 becomes 2, 3. The ordered pair of 1, -1 becomes, and the ordered pair of -1, 4 becomes 4, -1. Easy enough? And then, what about the table of values for g inverse?
Switch g.
Yeah, you're switching x and g of x. So, the first point of 3, -1 becomes, are we there? 1, 0 becomes 0, 1. -1, 3 becomes 3, -1. Okay, you have your chart there, yes? See what you can figure out about part C. Funny enough, I just thought of you a moment ago. I thought, oh, I wonder if he remembers. There you go. Okay, guys. f of g inverse of 0. You have all the information you need in your charts up above. Remember on these, we always start on the inside, yes. This is algebra pre-calc review. G inverse of 0. What's G inverse of 0? 1, yes? So now that's going to be 1 on the inside. And now you're being asked, what's f of 1? Negative 1. Enjoy the easy peasy while we can, right? Okay, f inverse of f of negative 1. F of negative 1, 4. F inverse of 4, negative 1. Notice on that one, folks, what we just put together. A function f and its inverse. And what did it equal? It equaled its input, right? Okay, so just realize we basically just undid it there. So it doesn't work with f and g because they're not the same function, but it does work there. Okay, f inverse of g inverse of negative 1. So g inverse of negative 1? 3. F inverse of 3.
2. Are we stuck?
Stuck would be a good way to put it. Why are we stuck? F inverse of 3, we don't have an x value of 3. So within this information, I have it written as not defined. Okay? In other words, with this specific table of values, we don't have that information. Okay? So it is not defined in our information we have here. I think I have not defined or undefined as the options in my notes. And one more. F inverse of 4. Negative 1. So then we do G inverse of negative 1. 3. Okay. That right there, folks, is an exercise in just understanding inverses. Okay. Keep in mind, they had us make charts here, yes? Okay. You may have to grab extra pairs, but we won't necessarily always have charts. So realize, if it says F inverse of 2, if you don't have that chart, you may just have to be like, okay, F inverse of 2, there's 2, so it's 3. Okay. Well, in other words, if you don't, and I guess you can always write out a chart if you need to, but just realizing F inverse just switches those two. Okay. Okay. The existence of an inverse function. Okay. 2 things. 1, a function has an inverse function if and only if it is 1-to-1. Okay. 1-to-1, remember it passes the horizontal and vertical line test. And then 2, if f is strictly monotonic on its entire domain. So, if a function is either strictly increasing, so just going up like a line or a cubic, or strictly decreasing on its entire domain, then it is 1-to-1 and therefore has an inverse function. So in other words, any type of graph that is always going up or always going down, so it doesn't have the ups and downs that could cause the problem, it's always going to pass a vertical line test, and it's always going to pass a horizontal line test. Okay? So it will have an inverse function. Now, what we have right here, the relationship between a composite function and its inverse is stated below. If you use the chain rule and differentiate both sides, we're going to be able to find a formula for the derivative of an inverse. Okay? Now, with that in mind, essentially we're kind of doing a proof here. okay, and just understanding what the pieces are. I think for notation purposes, this is what I did in my notes. For notation purposes, off to the side, I'm going to come off to the side here, and I'm going to define, actually I need to do it the other way. I'm going to define G to equal F inverse, because otherwise it's going to get confusing writing our F's and our F inverses. Okay, so basically going to take this and rewrite it. Instead of F inverse of X, we're going to say this is F of G of X, and it equals X. Okay. Now, we're trying to find a formula for the derivative of an inverse. So we're trying to find the formula for G prime of X. Okay. We're going to start by taking the derivative of both sides. So I'm going to indicate that by using the d dx out front. So the derivative of f of g of x, and taking the derivative of the right, so the derivative of x. Okay, that's just notation purposes. Okay, that's stating what we're going to do. So on the left, what's the derivative of f of g of x? We've been there, done this.
It's f prime of g of x times g prime.
Are you guys with her? The derivative of the outside, so the derivative of f of g of x is f prime of g of x times the derivative of the inside. Good. Equals, what's the derivative on the right? Okay. Derivative of x is 1. And this is all with respect to x. So we don't have to worry about anything fancy there. Now, we want a formula for the derivative of an inverse. What are we using for inverse right now? G. So we want a formula for G prime. How do I get G prime by itself?
Divide by like that first piece.
Okay. So in order to get G prime of x by itself, we're going to divide by the f prime of g of x. So I'm going to have 1 divided by f prime of g of x. And there's your formula. Now, I'm going to rewrite it the traditional way we see it. And that is by substituting back in that what did G represent? F inverse of x. And so now when we write this, never remember where to put my derivative mark. This is the confusing part. So G is the same thing as F inverse, all right? So I'm writing F inverse prime of x. So we're doing the derivative of f inverse. You got to be careful not to confuse the derivative and the negative 1, right? And then it's going to be equal to 1 over f prime of, instead of g though, I'm going to go back to f inverse of x. Okay? That's our official formula there. And now you can maybe see why it's not unusual for them to substitute G for F inverse. Because it's kind of confusing otherwise. Okay? Now, we're going to use this formula. You're going to get to the point where you know this formula. It looks bad, but if you have the right values, it's not bad. Okay? It just depends how hard you have to work to find what you need. Okay? So, hold on to that formula. I believe, yeah, that formula is in steps at the top of the next page when we get there. Okay, so you do have it in your notes. What?
Secret formula.
Secret formula? Okay, so let's look at example 2 here. We're going to try and use this formula, okay? So, we're given here a function. F of x is defined to be 4x minus 3. And we're given the fact that the derivative at 2 is equal to 4. And they want us to find the value of f inverse of 5, the derivative of f inverse of 5. Okay? Now, I'm going to start us with what was our formula from above. Okay? And then we'll do some filling in. So our formula from above was the f inverse prime of x, and that's equal to 1 over f prime of f inverse of x. Okay? That's the formula we're using, so to speak. What are we trying to do? We're trying to find this at what? At 5, right? Sorry, I was looking at my notes and I have steps written down, I think. So we're trying to find f inverse, the derivative, at 5. Well, that means if you're plugging in 5 for x, it's going to be 1 over f prime of f inverse of 5. Okay. Got it? Now, if you kind of start on the inside here, what do we have to find? We have to find f inverse of 5, right? Now, keep in mind that that is the inverse notation. Okay? Normally, in a normal situation, f of x equals a number. So, okay, sidebar with here. If f of x equals some number, then this is x and this is your y, right? Okay. What happens then when we start talking about f inverse of x? They just switched, right? So the idea here is when it says f inverse of x, this is actually the y value for f. Okay? And that's the part that you have to work to understand. And maybe I'm not doing a great job understanding it. Thank you. Okay, so we're going to sidebar for a moment. Over this way, I guess. I guess I'm full of sidebars today, aren't I? F of x is another name for what? Y, yes? So this equation, y equals 4x minus 3. Keep in mind, we need to know f inverse of 5. And 5 is what kind of value? Because it's the input of an inverse, this is a y value. So how can I find x when y equals 5? Yeah, can we go over here and put it in? And so have the equation 4x minus 3 equals 5. Okay, basic math, basic algebra. We did the crazy algebra earlier. This is the easy algebra. 4x minus 3 equals 5, so what do we know? Four x equals 8, x equals 2. So what is that 2? That 2 is, when you plug 2 in to f, to this function, what do you get out? You get out 5. So if f of 2 equals 5, what does that mean? F inverse of 5 equals 2. Are you with me? I know, first time through, you have to process through. So, what can we fill in right here? F inverse of 5 is, okay, so I'm at 1 over F prime of F inverse of 5 is 2. And they just so happened to give us F prime of 2, didn't they?
Oh, they did. 4.
And so this becomes 1/4. So for the record, another way to write the derivative. Okay, another way, up here I showed, and this is probably the more common way, F inverse prime of 5. You could also say F inverse of 5 and then a prime mark like outside a set of parentheses there. Okay. More common would be to find F prime of 2 is that you would have to actually take the derivative of F and then plug it in. What is the derivative of F? What's the derivative of 4x minus 3?
4.
4. So F of any value is going to equal 4. Okay. Seems confusing, but we didn't do difficult math here, did we? Okay. So.
That's what the next page is for.
The difficult math? I don't know. I'm trying to remember what's on the next page to know if I want to. Okay. In this next page, first of all, kind of gives us some steps, okay? And I kind of followed those steps, I think, if I go back and pair them up. So let G and F, I can't even read, G and F and G be inverse functions such that F of G of X equals X and G of F of X equals X, where F of A equals B and G of B equals A. So this is F of A equals B, A is the input, B is the output. On G, the inverse, B is the input, A is the output. To find the inverse at B for a point AB on F of X. I guess first of all they say find the derivative. We didn't have to find the derivative on the last one. If you're only giving B, you have to set B equal to F of X. That's what we did on that last one to find A. You find F prime at that A value, and then you're plugging it all in. This right here, folks, this is that formula you're going to need to know. Okay? The derivative of an inverse. That's what we're doing. We're doing the derivative of an inverse. And it's 1 divided by F prime of F inverse of X. So the derivative at the inverse point. And then just another fact that will be helpful. Inverse functions have reciprocal slopes. So that will be helpful as we proceed at times too. Okay. Example 3. They want us to find G prime of -1, where G of X is the inverse of F of X. So right there, G of X is the inverse of F of X. So G is the same thing as saying F inverse, right? Yeah? That's all. That's just fancy speak, okay? So G is often the inverse here. Now, long term, they want us to find G prime of -1. I'm trying to remember, do we have to fill in all these boxes, or is it just, I don't know. We're going to fill in all the boxes. I'm trying to remember the order I did this.
Is the first 1 and 2?
Is the first what?
Box 2.
Yeah, I mean, so I have in this box, so G of X, so With f of x, it's the ordered pair 2, 5. I have in this box written the 5, 2, but it is essentially the g value is the 2. Yes, is that what you were saying?
I think so.
Yeah. If we go ahead and fill those out, okay. What about in the next row?
Negative 1 and 3.
-1, 3. And in the bottom row? 4, -1. Now, in this next box, if it's g prime of x, then that is the derivative of the inverse. Realize that, right? It is the derivative of the inverse is what they're asking for there. Now, I just said there's a key fact up above, yes? Inverse functions have reciprocal slopes at corresponding points. So, we're looking for g prime of x, so we're looking for the derivative or the slope of the inverse. What were we given back here in this third column? We were given the slopes of the original function, yes? We'll start off with the trickiest one, I guess. Thoughts on what the derivative of f prime is going to be, or g prime? Inverse functions have what? Reciprocal slopes. What's the slope of the original function? At 2, 5, the slope is 0. What's the reciprocal of 0? No?
Doesn't exist.
Doesn't exist. Because I think of 0 as a fraction of 0 over 1, right? So if this is 0 over 1, the reciprocal is 1 over 0. Well, 1 over 0 is that undefined slope that I probably have D and E written down. Yeah, I have D and E written down. Okay. At the ordered pair 3, -1, f prime is -4. What's g prime?
-1/4.
-1/4. It's the reciprocal. That's all I'm doing. It's the reciprocal. G prime is going to be the reciprocal of f prime at the equivalent point. Inverse functions have reciprocal slopes at corresponding points. At the point -1/4, the derivative is 6. What's the derivative of the inverse then?
1/6.
Reciprocal of 6, which is 1 over 6. Now, they actually asked us to find g prime of -1. Realizing g is the inverse, right? Did we end up finding that eventually?
Yeah.
We did. Okay, that's one of my boxes there. Remember, though, the formula, okay? With the fact that g prime is g is f inverse, this is the same thing as filling in that formula up above. 1 over the derivative of g, started to say of x, but our x value is -1. Okay? I want to show you the connection here. 1 over f prime. What's g of -1? G of -1 is 3. F prime at 3, what is f prime at 3? -4. So we end up with -1/4. Well, the derivative of g of -1. So that's looking right here, yes? Does this answer make sense? If -1 is the input of g, it's the output of f, -1, and that slope is -1/4. Okay? we're going to be working with this formula, okay? We're going to work with this formula a lot. So, tomorrow, we'll pick up there. Hopefully, with luck, we can get the notes done and stay on track. What's tomorrow, Wednesday? Okay. That means Thursday we'll be starting 3-5. And we'll see how things go as to what I do on Friday. Whether I finish 3-5 on Friday with a couple of you, or whether we just wait and finish 3-5 with everybody on Monday, I don't know. We're going to see what happens. Fair enough?
Yeah.
So, no matter what, test will be next Thursday. I guess I can't say no matter what, but
Most likely.
that is